in this lesson, we're gonna talk about how to classify systems of linear equations. And remember, we're only talking about a system consisting of two linear equations, only two. So in a previous lesson, you learned this. You learned that when we solved a system by graphing, we saw that the lines could intersect, right? And remember, the point of intersection is called the solution. We also learned that the lines could overlap. So we saw that. So we saw that we had a line that did this and the other line did the same thing. So those two lines overlap. Okay? We also solved a system where we saw that the lines did not intersect, meaning that they were parallel and had different y-intercepts. All right, so those are the three things that we saw when we graphed these lines. So the lines could intersect, they could overlap, so these two lines overlap, or they could not intersect. Okay? So if a system has at least one solution in our case will be one or an infinite number because we're dealing with two equations. Then we call this consistent. So if in these two cases here, these systems, if it has at least one solution, we say that this system is a consistent system. So consistent. Okay, consistent. So if we have one solution or an infinite number solution, then we say it's consistent. consistent. If there is no solution, we say it's inconsistent. Inconsistent. So consistent, you have one solution or an infinite number. Okay? Inconsistent means you have no solution. Okay, now we can go a little bit further. We can dig a little bit deeper, and this is going to be important what I'm about to tell you. So the equations can be independent or dependent. So let's talk about what independent equation is. An independent equation is an equation in a system which cannot be derived algebraically from other equations. So an equation in a system which cannot be derived algebraically from other equations. So we're going to look at what that means in a little while. If an equation is independent of the other equations in the system, then it provides information beyond what? Beyond that which is provided by the other equations. A dependent equation is an equation considered dependent if it can be obtained by multiplying the other equation by some number. If an equation is dependent on the other equations, then that equation provides no additional information not contained in the other. This equation can be dropped from the system without any further loss. All right, so it's a lot of things I just said here, but basically here's the idea. All right, so listen carefully. I'm going to go back to our lesson that dealt with this. All right, so in our previous lesson. So you may need to go back and look at that video from the previous lesson. Do you remember when we looked at this equation right here in our previous lesson, this system? And when we graphed this system, we had this. Okay, remember that? So those two lines intersect at one point, right? Okay. So we consider this each line independent of the other. We consider each line independent of the other. Okay, so what that means is this. If you have a consistent system, then the lines that intersect at one point, they're independent of the other. So this would be independent. Independent. Okay? And if the lines overlap, they're considered dependent. All right, so we're going to talk about that a little bit further. So it's pretty easy to understand why this system is consistent and why this system is inconsistent, because the definition is straightforward. Consistent system has one, in our case, we're only dealing with two equations, one solution or an infinite number solution. All right, so one solution or an infinite number solution, right? So that's easy to understand. An inconsistent system has no solution. The difficulty is understanding what we mean by independent, dependent. Okay, so I'm going to go back to our definition right here. So listen carefully. So an independent equation, each equation cannot be obtained algebraically from the other. All right, I'm going to go to the dependent. A dependent equation means that an equation is considered dependent if it can be obtained by multiplying the other equation by some number. So if I go back and look at that first system right here, if I multiply either of these equations, if I multiply both sides by 2, will I get this equation? No, because that's 2y, and that's going to be 8x plus 6, right? I'm never going to get this. If I multiply this by some number, let's say 3 or 1/2 or 2 or -6, will I ever get the other equation? No. No matter what you multiply this equation by, you're never going to get that. Again, I'm going to say this. No matter what you multiply this equation by, you are never going to get this. Because the reason is if I multiply this side by 2 and multiply this side by 2, then that's still going to be y, right? So no matter what you multiply this equation by, you're never going to get this. No matter what you multiply this equation by, you're never going to get this. So since each equation is independent of the other, we say that each equation is independent. So this equation I can't get from this equation. So each equation is independent of the other. Okay? Now, let's look at that other system we had. Okay, so the other system. Okay, so in the previous lesson, we looked at number 4. Okay, number 4. So remember, when we graphed this, when we graphed number 4, when we solved this system, remember we got slope-intercept form. So notice that the slopes were the same and the y-intercepts were the same. And so we had an infinite number solution. So remember, that's where the graphs overlap. Remember that? Okay, so that's this situation right here. So that's this situation right here. So this system, this right here, where you have an infinite number of solutions, that's this system right here. Okay, so I want you to notice something. When we graph this, the slopes were the same and the y-intercepts were the same. Okay, the slopes were the same. The y-intercepts were the same. When we graphed a system where it intersected only at one point, I want you to notice something. The slopes in both cases were different, right? Slopes were different. And it doesn't matter about the y-intercept. The y-intercept turned out to be different, but basically the slopes are different, right? So those were two separate equations. Okay, that was this kind of situation. So I want you to go back to this one. So we're going to go back to number 4. So remember in our definition right here, in our definition for dependent, it says that an equation is considered to be dependent. And we know now that if the lines overlap, then the equations are dependent. If the lines overlap, the equations are dependent. If the lines intersect, the equations are independent. But let's go a little bit further. Let's understand why. So a dependent equation is an equation if it can be obtained by multiplying the other equation by some number. So let's go back now to number 4. Remember number 4, the slopes are the same, the y-intercepts are the same, which meant that the graphs overlapped. Okay, I want you to look at the first equation and look carefully what I'm about to say. If I take that first equation right here, okay, if I take that first equation, y equals 2/3 x minus 2, can I multiply this equation, both sides of this equation, by some number and get this equation? Some of you may say yes, some of you may say no. Well, let's think about this. What is the coefficient of y right here? Coefficient of y in the other equation is 3, right? This is what coefficient? 1. So let's go ahead and multiply by 3. So if I multiply this side by 3, so let's multiply by 3. So if I multiply both sides by 3, I get this. I get 3y equal 3 times 2/3 x minus 2, right? So I multiply both sides by 3. What you do to one side, you do to the other. So now I'm going to distribute. So I get 3y equal 3 times 2/3 x is 2x. 3 times a negative 2 is negative 6. All right? Now remember, I'm trying to see if this is this. Well, almost, if I subtract 2x, I get 3y minus 2x equal negative 6. And isn't that what this is? So was I able to multiply one of these equations by some number and get the other? Yes. I multiplied this equation by 3 and I got this equation. I multiplied this equation by 3 and I got the other equation. So I was able to take one of those equations, multiply by some number, and get the other. So what that means is this. What that means is that each equation is dependent on the other. So this means that each equation in the system is dependent of the other. Okay? If I cannot do that, if I cannot multiply, let's go back to number 1. If I cannot multiply the first equation by some number and get the other, or the second equation by some number and get the other, then they are independent. So these two would be independent of each other. Okay, so let's go back and talk about this. So this system where we had y equals 2/3 x minus 2 and 3y minus 2x equal negative 6. This is from the previous lesson. Each equation is dependent on the other. Okay? And the reason is because I can take this equation, multiply it by 3, and get this equation. Vice versa, I could divide this equation by 3 and get this one. Okay? This system, this one here, from the previous lesson, this system, y equals 4x plus 3, y equals negative x minus 2. There's no way you can multiply this equation by some number and get that one. And the reason is because these are the same coefficients, right? So if I multiplied this by 2, then if I multiplied this by 2, then I would have to multiply this by 2, which means that these sides would be different. So each equation is independent of each other. All right. So the statement we had earlier here and here. So independent equation is an equation in a system which cannot be derived algebraically from the others. A dependent equation you can multiply, can be derived algebraically, so meaning that you can multiply one equation by some number and get the other. Now let's look at these other statements. So that statement here that says if an equation is independent of the other, then it provides information beyond that which is provided by the other equations. This says that if two equations are dependent on each other, then you can basically toss one of them out without losing anything. So here's what I mean by that. When I solve this system right here, when I solve this system, both equations were needed, right? Both equations were needed because the slopes were different. The slopes were different and the y-intercepts were different in this case. They can be the same, but basically the slopes are different. They intersected at one point. So I needed both of them. So this equation provided me information about the slope that was different from this equation. This equation provided me information about the y-intercept that was different from this equation. Whereas when I go to this one here that we did in a previous lesson, number 4, these are the ones that overlap. Notice both equations have the same slope and the same y-intercept, right? Same slope and same y-intercept. So does this equation have any different information than this one? No, they provided the same information. This equation has the same information as the other equation. So that's why we say that this equation is dependent on the other. Okay, so you may still have difficulty understanding what we mean by independent and dependent. But for right now, just know this. A consistent system has one solution or an infinite number of solutions. Inconsistent has no solution. So that's why they parallel and don't intersect, right? They don't have the same y-intercept. If the systems are not the same, if the equations are not the same equation, they're totally different, then they're independent of the other. If the equations are identical, they overlap, then they're dependent. Okay? Now let's look at this system right here. So that was one that was a parallel, remember? Okay, that was one that was a parallel. So let's look at that one. So that was number 3. So remember we graphed number 3 right here. We had these two parallel lines that did not intersect. They had different y-intercepts. Okay? So here's my question. We know that this system is inconsistent. Okay? Because it has no solution. Here's my question though. Are these equations independent or dependent on each other? All right, so again, are these equations independent or dependent on each other? Well, if they're dependent, then that means I can multiply one equation by some number and get the other. So you see how this is a 2y right here? Let's multiply this by 2. Let's multiply both sides by 2. All right, so I'm going to go ahead and do this on another sheet of paper. So I'm going to go ahead and I'm going to rewrite this system right here. 2y equal negative 4x plus 6, and then y plus 2x equal negative 1. Okay? So what I'm going to do is I'm going to multiply this side by 2 to get a 2y, or if I want to go from here to here, I can divide both sides by 2. Doesn't matter. Let's just go ahead and multiply by 2. So we're going to take this equation, multiply by 2. And let's see what we get. So we get 2 times y plus 2x equals negative 1 times 2. So what I do to one side, I do to the other. So I multiply this side by 2, I multiply that side by 2. Then distribute, I get 2y plus 4x equal negative 2, right? So the question becomes this, is this right here the same as this? Well, let's see. So over here I got 2y by itself, so let's get 2y by itself. So I'm going to subtract 4x. So I get 2y equal negative 4x minus 2. So here's my question. Is this the same as this now? No. What's different? This constant. That's a 6, that's a what? Negative 2. So here's my question. Can I take this equation or this equation, multiply or divide by some number and get the other equation? No. So each equation is independent of the other. Each equation is independent of the other. So here's the point I want to make now. So some textbooks, let me just say this, some textbook will stop here. And they will say a consistent system, the equations are either independent or they're dependent. And then they'll say, okay, an inconsistent equation, we're not even going to talk about this. Well, some textbooks do. And so here's the thing. So remember our definition of dependent, meaning that I can take one equation, multiply by the other and get this one. And remember, those were not independent. So, I'm sorry, those were not dependent. So dependent means I can take one, multiply by the other and get this one. All right, that's dependent. So I couldn't do that here. So those two equations are independent. So an inconsistent equation will always be independent. The equations will always be independent. Okay? All right, so a lot of information here, but basically you just need to know this. When classifying systems, either the system is consistent or inconsistent. If it's consistent, it means that you have at least one solution. In our case, it will be either one solution or an infinite. Inconsistent means you have no solution. You can go further and talk about the equations. Either the equations are independent or the equations are dependent. In a consistent system, if the equations inconsistent, remember they intersect or they overlap. If the equation you get one solution, then the equations in the system, if you get one solution, then the equations are independent. In the system, if you get an infinite number of solutions, then the two equations are dependent on each other. If they're inconsistent, meaning that the lines are parallel, you have no solutions, then the equations are independent. Okay? All right, so that was the gist behind the classifying of systems. The more difficult part, though, was understanding why do we say this is independent and why do we say this is dependent? Why do we say this is independent? All of that understanding comes from these statements that we made here. So understanding what independent and dependent means in terms of these statements here will help you to understand why something that looks like this is independent, the equations are independent, why these two equations are dependent, and why these two equations are independent. Okay, so that is the end of our lesson on classifying systems.